You know, we've all got this kind of built-in riskometer, right? It's what helps us get through the day. But here's the thing. A lot of the time, it's just completely off. So today, we're going to dive into the science of risk and hopefully give that internal meter of yours a serious upgrade.
All right, let's kick things off with a simple question. Imagine this. You've got to get from Washington, D.C. all the way to San Francisco. You've got two options, fly or drive. Now, which one feels riskier? And be honest with yourself here. What's your gut screaming at you?
I'm willing to bet that for a lot of you, the answer is flying. I mean, it makes sense, right? You're strapped into this metal tube, you're miles up in the sky, and you have absolutely zero control. It just feels dangerous. Driving, though, that feels familiar. We're behind the wheel. We're in charge. Or are we? What do the actual numbers have to say about this?
Okay, get this. The statistical chance of a fatality on a single commercial flight, it's less than 1 in a million. In fact, a lot of experts will tell you that the most dangerous part of your trip is the drive to the airport. So, what is going on here? Why is our intuition so incredibly wrong about this?
Well, this huge gap between what we feel and what's actually true, that's something called the risk paradox, and it's all about a fundamental quirk in how our brains are wired to deal with danger.
And this really gets to the heart of it. Our brains are basically programmed to fixate on these big, dramatic, but super rare events, like a plane crash. At the same time, we just sort of ignore the common, everyday risks we face all the time, like getting in the car. So, if our gut feelings are this unreliable, how do the experts approach it?
To really get a handle on this, we have to step away from our feelings and look at a more structured way of thinking, and that's where risk science comes in. It gives us this really simple but incredibly powerful formula. It breaks down any risk into just 3 core parts.
Okay, so first up, you've got the event. Let's just call it A for short. This is pretty straightforward. It's the thing that might happen. The plane crash, the car accident, a global pandemic, whatever specific hazard or threat we're actually talking about. Next, part 2, the consequences. We'll call this C. This is all about what's at stake if that event really happens. And we measure this in terms of things that matter to us, right? Things we value, like human lives, our health, our money, or damage to the environment.
And finally, the third piece. And honestly, this might be the most important and most overlooked part of the puzzle. Uncertainty. Let's call it U. This is basically everything we don't know. What's the real chance of this thing happening? What will the exact consequences look like? You can think of uncertainty as this fog we're all trying to peer through.
So, here's the big idea. In risk science, risk isn't just one simple thing. It's actually this combination of 3 elements: the event, A, the consequences, C, and the uncertainty, U, about both of them. This is the mental model that the pros use, so why is it so darn hard for the rest of us to think like this?
Well, the answer is all in our heads, literally. In our psychology, researchers have this idea that we basically have 2 different ways of thinking. You can almost call them 2 brains, and they're constantly battling it out to make sense of the world.
So you've got System 1. That's your gut. It's fast, it's automatic, it's all emotion. It's a part of you that's screaming, "We're going down," when the plane hits a little turbulence. Then you have System 2. That's your rational brain. It's slow, it's analytical, it's methodical. It's a part that can actually look at that ACU formula and make a calm, calculated decision. The big problem? System 1 is a drama queen, and it loves to hijack the whole process.
And research has actually pinpointed the exact triggers that set off our emotional System 1 brain. We're talking about things with high dread potential. Risks that just fill you with fear or anxiety. Also, situations where you feel like you have no control. New and unknown threats are a big one. And of course, anything with catastrophic potential. Think about it. A plane crash. It literally checks every single box. And that's exactly why it feels so much more dangerous than it really is.
So how do the experts fight back against this emotional takeover? Well, they use specific tools that are designed to force their brain to slow down and use that analytical system too. Let's take a look at the most common one they use. Okay, so this right here is a classic risk matrix. It's a standard tool of the trade for professionals. It's just a simple grid that helps you map things out visually. On one side, you've got probability, going from low to high, and on the other, you have the consequences, from minor all the way to catastrophic. So obviously, something with a high probability and catastrophic consequences, that's going to be your top priority. Something with low probability and minor consequences, not so much. It's a really simple but effective way to sort and prioritize risks. But there's a catch, a big one.
This whole beautiful matrix depends entirely on that probability axis. And what happens if our number for probability is, well, just a guess? Or it's based on really shaky data? How much can we really trust our own assessment then?
And that leads us to the single most important thing you can ask to take your own risk assessment from an amateur level to a true expert level.
Because the real pros, they know that a simple 2x2 grid like that can be super misleading. They add a crucial third dimension to their thinking, and it's one that completely changes the game. It's all about the quality of the information itself.
Okay, check this out. This is the extended risk matrix. See that last column? Strength of knowledge. This is where the magic happens. Let's compare two things. A plane crash. Consequences are catastrophic, but the probability is super, super low. And, critically, that number is based on strong knowledge from decades of solid data. Now, let's look at something like a brand new virus. The consequences could also be catastrophic, and maybe we guess the probability is low. But here's the key difference. The strength of our knowledge about that probability is weak. It's all based on assumptions, not hard data. And that is what makes it a massive risk that we have to pay attention to.
So what exactly is this strength of knowledge, or SOK as it's sometimes called? It's really just a judgment call. It's about the quality of the information you have. Is your probability estimate based on tons of solid, historical data, like with airline safety? Or is it based on some flimsy computer model that's packed with a bunch of unproven assumptions? The bottom line is, not all probabilities are created equal.
There's a quote from the source material that just nails this. It says, "To conclude on an activity being safe, it is not sufficient that the derived probability of a negative outcome be low. The knowledge supporting this probability also needs to be strong." I mean, that's it right there. A low probability number means absolutely nothing if it's not backed by strong evidence. You might calculate a low chance of a new virus becoming a pandemic, but if that calculation is just a guess, the real risk could be absolutely enormous.
And really, that is the key takeaway here. Upgrading your own personal riskometer isn't about throwing your intuition out the window. It's about arming it with a much better question. So the next time you're trying to figure something out, don't just stop at, what are the odds? You've got to go one level deeper. Ask yourself, how strong is the knowledge behind those odds? That single question is how you start to think like a real risk expert.
Let's reflect a bit on this video, because we cannot just trust an AI-generated video. So it mentioned the risk matrix, and I think the risk matrix itself was explained well, but he said in the video that it's an effective tool for risk analysis, which is not necessarily the case. Also, he did mention the main reason why strength of knowledge is not reflected. It only looks at probabilities. But there are more problems with the risk matrix, which is very well explained in this fundamental paper by Anthony Cox, What is Wrong with Risk Matrices. There he lines out the axioms a good risk matrix should have in order to be used effectively. But at the same time, in the discussion of the risk matrix, it is important to note that it is a very commonly used tool in the industry. And one of the main examples of that is that it's referred to in the ISO standard 31010, which basically goes together with 31000. So 31000 explains what you should do for risk management, but 31010 gives you the tools on how to do that. So it goes into the methodologies. And there you can see that it is the risk matrix is referred to in figure B17, and it's used as explained as a risk management tool. So the key takeaway is, yes, there's a lot of methodological problems with it, and there's a lot of consensus in academia about that there are problems with it, but at the same time, it is very commonly used in the industry. So we should also acknowledge that it does provide some value. If you want to learn more about it, I've written my thesis on the risk matrix, so you can read that. And I've also written some blog posts about alternatives to use as a risk matrix. So I'll link to that below.